Hello. In this video, we're going to look at graphing a system of linear inequalities. So in the two videos which preceded this, we graphed just one linear inequality. Here, we're going to follow the same practices as in those previous examples. We're going to graph each line on this Cartesian plane. And then we would look at shading each line appropriately. What would be the shaded region for each line? Now, the region that gets shaded twice, where those two shaded regions overlap, only the overlap, is the solution to the set of the system of equations. And I'm noticing that says equations there, but we are dealing with inequalities. So let's look at each of these. First thing I'll do is I'll take this guy, I'll treat it like an equation, x plus y equals 3. And the only thing that inequality is telling me is where to shade and whether or not it would be solid or dashed. In this case, we know we're going to draw that with a solid line. Now, if I rearrange this, that would be the same as y equals negative x plus 3. So that line has a slope of -1 and a y-intercept of 0, 3. I'm going to plot my y-intercept there, and then I'll travel down 1 over 1, down 1 over 1, etc. I'm drawing my line with a slope of -1. And now, because we had an equal to on our inequality symbol, when we draw this, we know it's going to be a solid line. We'll look at shading for this here in a second. Now let's look at the other inequality. Here I have x minus y equals 1, and we know this will be dashed, of course, because the inequality symbol doesn't have an equal to. So that's the same as x minus 1 equals y. This guy, we have a slope of +1 and a y-intercept of 0, -1. So I'll put my y-intercept in here, and I will draw my positive slope. And now, of course, this is a dashed line, as we just said, so I'll draw my dashed line in here. Now, essentially, we have divided this plane into 4 regions, and only one of these regions represents the solution set. So now what we're going to do is we're going to test an ordered pair that's not on either line in each of the original inequalities. So again, the origin is a very nice choice, 0, 0. Reminding you right now, the only time you can't choose that origin is whenever the line is passing through it. So if it was passing through it, I would just pick another point nearby, easy to deal with, like 1, 1 or 0, 1, etc. So let us test the origin in the first inequality. 0 plus 0 is greater than or equal to 3. Is 0 greater than or equal to 3? Now that is a false statement. So since I'm not including 0, 0, that means I would be shading above or kind of over to the right for this inequality, which if it was just 1 would look something like this. But we have to deal with both, the overlap. So let's look at the other inequality. Again, I'm going to test the origin. 0, 0. That gives me 0 minus 0 is greater than 1. Is 0 greater than 1? Again, that's a false statement. So I do not shade in regard to the blue line containing 0, 0. I would be shading over here. So we previously included this region, and you can see right here, this is where the orange and the green or the blue and the red regions are overlapping. So my solution set, the only region I would be shading would be that dual region. That means I can pick any point in this purple region and it will work in both The original inequalities, it works in both of those simultaneously. So any ordered pair in this region, it can be on the red boundary, but not on this blue dashed line. And that's how we deal with a system, multiple equations of linear inequalities.